Okay, today we're looking at section 3.1 and we're solving the question of how do you solve systems of equations by graphing. So before we get into solving systems of equations, we need to know what a system of equations is. So in this section, what a system of equations is two equations with two unknowns. And in this section, we're going to focus on linear equations. So for example, I could have 3x plus 2y equals negative 4 as one equation, and x plus 3y equals 1 as another equation. When I say I want to solve that system of equations, what I want to solve for is what x and y coordinates satisfy both equations. So for all of these systems of equations, and in this section these are linear, so when we graph on their lines, we're looking at on the graph where do these lines intersect, and that's our solution. So a line could intersect at one point, it could not intersect at all if it was parallel, or it could intersect at infinitely many points if the lines are the same lines. So those are our three possibilities. So in this section, we're going to focus on graphing to find the solution. So let's start with this one then. So let me make my XY axis and let's graph. So let's start with the top one, 3x plus 2y equals negative 4. So we could solve that, or we could graph it by finding intercepts, or we could solve for y and do slope intercept. So looking at it, because it's in standard form, let's just find intercepts. So if I plug 0 in for y, or 0 in for x, and I solve for y, 2 times negative 2 is negative 4, so that's 0, negative 2. If I plug in 0 for y, I get 3x equals negative 4. Divide by 3, I get negative 4/3, which is a fraction. A little bit more difficult to graph, but we can do it. So let's graph that line. 0, negative 2, and negative 4/3, 0. That's negative 1 1/3. Okay. Make sure you use a ruler in this section to be a little bit more accurate. All right. Second line. Plug in 0 for x. Divide both sides by 3, I get 1/3. Again, not an ideal value. Plug in 0 for y, x is going to be 1. So 0 and 1/3 and 1, 0. Okay, those are our coordinates. So if I connect those. Okay, so our solution to our system of equations is the coordinate where these lines intersect, which in this case is negative 2, 1 on my graph. If you're not accurate with your graphing, you're going to have a hard time finding that point of intersection. Now let's check and just verify that this is the solution. It should work in both equations. 3 times negative 2 is negative 6. 2 times 1 is 2. Negative 6 plus 2 is negative 4. So that works there. Negative 2 here. Negative 2 and 3 times 1 is 3. So negative 2 plus 3 is 1. So this coordinate works in both equations. So that's my solution to my system of equations. It's the only coordinate that'll work in both equations. All right. Let's move on. Let's try a second one here. 4x minus 5y equals negative 10, and 2x minus 7y equals 4. Go ahead and try that on your graph paper. Pause the video and then run it again, see if you get the right answer. Alright, so Let's find intercepts on this one just like we did the last one and see what we get. Y-intercept, plug 0 in for x, divide by -5, I'm going to get 2 there. Plug 0 in for y, divide by 4, -10/4, or 5 halves, which is -2.5, 2.5. So let's plot that 0, 2, and -2.5, 0. Okay, let's try the next one. 0 for x. Oh, this is not a very good fraction here. Divide by -7, I get -7 or -4/7. Plug in 0 for y, divide by 2, I get 2. So 2, 0, and 0, -4/7 is somewhere around -1/2, a little bit more. So right about there. Okay, so where's my point of intersection? Right there. Looks like it's -5, -2. So did you get, now if you, because of this point, if you put your ruler on there and came, you might have been a little bit closer to a different coordinate. As long as you graphed it right and you're close, we're in pretty good shape, but you can check your answer and see if you're in the ballpark. Okay, so if we plug -5, -2 in and it doesn't come out in both of these equations, we know we don't have the right answer, so we can try some other points that are close by here. But 4 times -5 is -20. -5 times -2 is a +10. Add those up, I get -10, so that works. 2 times -5 is -10. -7 times -2 is +14. That adds up to 4. So that does happen to be the correct answer for that one. Okay. Let's try another one. 2x plus 5y equals 6. And 4x plus 10y equals 12. Okay, let's find the intercepts here. Plug 0 here, divide, I get 6/5. And then plug 0 in for y and I get 3. Same thing for this one. Find the intercepts here. Plug 0 in for x. I get 12/10, which is also 6/5. Plug in 0 for y there. Divide 12 divided by 4 is 3. What do you notice about this? We have the same intercept, so if you visualize graphing it, we end up with the same line. Okay, so if it's the same line, we have infinitely many solutions. In that case, we don't even have to graph it. So let's check the next one last problem. 3x minus 2y equals 10. And 3x minus 2y equals 2. Okay, let's find the intercepts. 0. Plug in 0 for y, I get -5. Plug in 0 for x, I get -5. Plug in 0 for y. 10 divided by 3, 10/3. Okay, let's graph that one. 10 thirds, 3 1/3. So connect those points. And let's graph this last one. Plug 0 in for x, I get -1. Plug 0 in for y, I get 2/3. 2/3 0 is right here. Oops. So what do you have here? It looks like you have two lines that are parallel, so there's no solution. In that case. So the slopes are the same, lines are never going to cross, so there's no coordinates that'll satisfy both equations. Okay, so those are the different possibilities you could encounter in this section.